Be social, be the media guru.
Buonasera, buonasera a tutti.
Good evening once again, ladies and gentlemen. Now, this is really fantastic. Thank you. Thank you so much for being here. Thank you for your support. Thank you for your, curiosity. Because, tonight you will be feeding your minds and even your native fantasy. Now, if you are ready to travel at 1,000 kilometers an hour in something which is not an aircraft, well, you will see that there's something that will really bring us into the future. Now, first of all, I would like to wholeheartedly thank you for being here tonight. And okay, let me go through this list of things that I have to share with you now. This Meet the Media Guru meeting, and now this is the second meeting of many meetings together with Fondazione Bassetti and Francesca Semonai close to me. We put together because the key idea is to have many different points that we will, face together. We will be talking about mobility, and this is why the title is Around Mobility, with a cultural, professional approach. At the same time, we want to really focus on social aspects and social impacts of major changes. Because, mobility, well, especially for those of you who've been with us together with Amara, so of course mobility is one, well, it's a sort of a point. I mean, it's an issue concerning our lifestyle, the way we work and the way we live. So major changes are much more than social anthropological changes, which are so strong and deep. Now, with what we will do today, we will get into, if you will, a sort of a new technological scenario. Because, once again, this is, what we are doing right now. New algorithms, motors, engines, small engines, so many technologies. This has an impact on the urban planning, on the territory, because basically we are redesigning geography, the professional geography, economic and even physical geography, because there will be major changes. I mean, our cities will really be changing, and we want to think about cities the way we think of them now. So this is why we really would like to take a deep dive into these topics. So, well, first of all, I'm not the speaker tonight, but let me thank the Fondazione Bassetti, because Meet the Media Guru is now cooperating with them. I will also show you the list of the next meetings. First of all, we need to thank the Lombardy regional authorities. Thank you so much. We also have some projects that we are sharing with them on study, research, and mobility. Thank you so much, because there's a beautiful synergistic movement with them. I also would like to thank Repower. Repower is an energy company. It's a leading energy company. Thank you so much for your support. And it's a real thank you message. I mean, because it's much more than a thank you. It's much more than a couple of words. I mean, it's thanks to them that we can put together these meetings, together with the Polytechnic University of Milan. You know that the Politecnico here in Milan is working hand in hand with us. If I'm not mistaken, they also have a master course on mobility. So this is why it's so important, together with the Kari Plo Foundation. Now, Meet the Media Guru is an important program for us. We've been going on for 15 years. So if you keep coming, even if you have, let's say festivities or, holidays. Anyway, I'm sure the Cariplo and the foundation will be supporting us. Together with the big house of Meet the Media Guru, as we like to say, it is a former so-called Spazio Obada. So it's a building that's been rebuilt. And what we would like to do is to have a digital culture international permanent center. We will be doing creativity, art, and research. So this is one of the key priorities that we have. If you will, it's one of the key points that we have in our agenda. So once again, don't just imagine, the typical technological space. I mean, we will be, having meetings then, and we will be hosting, let's say, creative people. So we have top ambitions. Now, I'm not opening a membership campaign, but shortly you will be invited, to be there. So to really, let's say, join forces. I also would like to thank plenty of volunteers. And I keep forgetting, them. Mattia, for example, he's an artist. And he's now the cameraman tonight. So once again, he's shooting, he's a video maker, yes, but it's much more than this. He's working on the so-called live cinema. So next time you join us, well, be aware you will be included into a live movie, just like, a film director. So instead of doing post-production, it's, live video. And this is not a documentary, okay? Because once again, we really, really would like to remove barriers and then, exceeding frontiers. Back to mobility, Francesco, I'm sure that we will be we will keep talking about mobility, because this is one of the key topics for your foundation as well. So once again, this is a social, anthropological, professional, architectural, urban planning related aspects that we will be going through. And of course, we will be taking into account, there's a major change and a sort of a mutation, if you will, in our daily habits. So why do we have the involvement of this foundation, Fondazione Bassetti? Of course, we choose our partners in a very specific way, in a very purposed way. With you, we want to talk about responsibility and ethics. Francesco, can you give us some color about this? So once you thank all the institutions, starting from our host, just listen to Maria Grazia and remember that if Meet the Media Good has been here for 15 years, it's thanks to the ambition and the pleasure of doing innovation from Maria Grazia Mattei. Maria Grazia, thank you so much for this. Okay then, Fondazione Bassetti. For 25 years we've been working in responsibility and we do innovation. Of course, I won't be talking about what we have done for 25 years. I will just be, focusing on two key points that we will be dealing with tonight. And we have a real guru like Ryan Janzen. Now, he wrote that Napoleon was as slow as Julius Caesar. So Andrew Siegfried, a sociologist of more than 100 years ago, he thought of 1 century before. But the century before, so the 19th century, was a major step forward, an incredible leap forward. And, after a sort of immobility, a frozen situation for thousands of years. And of course, I'm talking about mobility, so moving quickly. So Napoleon was as slow 200 years ago, 300 years ago, as slow as Julius Caesar, so 2,000 years ago. Now, mobility has been transformed. So this means that people can move from one place to another. We can also move goods. And, this is something that's able to reconfigure, re-engineer the economy story and even the social story. But thanks to mobility, we've been able to create, for example, joint stock companies. For example, in the US, the major joint stock companies and corporations were created at the end of the 19th century to build railways. So once again, I will never repeat enough that mobility is the major social reconfigurator of our time, but also including, the previous or the past centuries. Well, today we have to share new questions, which is what we will be doing tonight. So in this era, this is the so-called zero time and zero space, because this is globalization and accelerated globalization. But we understand time and space are more important than ever. So even the opportunities, the possibilities that we have, for example, even in those places that are so near to us. For example, we can really do all of this very, very quickly. This opens up new conflicts. This means that we have obtained new opportunities, new possibilities. So it is useless, to get, onto the long discussion, for example, on the high-speed train line between France and Italy, which is a major issue for Italy today. Now, Ryan Janzen will be talking about this. So, this is the very last point I'd like to say. In terms of responsibility and innovation, we have to understand the following. Collective responsibilities are quite often encouraged by people that, in your opinion, are not interested in technology, because Today, we have to talk about sustainability and health of the planet. Now we have Greta, she's 16 years old, and she's able to change the world. Now, technologies today are taking us into the future, and I'm sure that this is representing a major leap forward, an incredible leap forward in terms of the new organizational settings of our societies, the ways our communities learn how to spend time together with no conflicts at all. So once again, I really would like to thank not just the MtMG and Meet, so the new cultural center here in Milan. I also would like to thank the Lombardy and Milan regional and municipal authorities. I also would like to thank all of you and plenty of organizations, because we need you and your help. We know what innovation is. So once again, it's not just for the sake of innovating, but of course we want to innovate because we know that we have new targets to reach and new systems that we have to leverage. Now, the Lombardy regional authorities are now working on mobility, and I'm sure there will be another opportunity and another meeting where to talk about mobility. Let's say that this is our first meeting in this regional authorities auditorium. I'm sure it's the first time, and there will be many more meetings. Now, Ryan Janzen is here with us, so please, let's offer him a big round of applause. Ryan Janzen here on stage. So, while waiting for Ryan, I have a short bio. Now, he's a scientist, and I met Ryan in Toronto in Canada, so we met him some months ago. So he's so-called a citizen of the world, but he's also an artist, and which is what we like a lot. Okay, Ryan, the stage is here for you. Thank you, Ryan. This is for you, and of course, we are men-centric, in our reflections. So thank you so much. Thank you, Ryan.
Well, it's a pleasure to be here, and thank you to Maria Grazia and the whole team at Meet. I feel that Milano is a very appropriate place for many of these topics, so it should be good. I'm going to talk to you about designing the future, thinking holistically about engineering, design, and the arts, and how we can see what's coming next, but even better, to create what's coming next. So I'm going to show you some of my work with transportation and other areas of design and even the arts. So it will bring in a few different disciplines that you might find interesting. So my background is partly from the research world and also the entrepreneurship world, starting a few different companies on the business side, purely academic side as well, and really just a few different areas of that you will see soon. And really, when we all of us are creating something new in the world around us, in our lives, and people who are designers or artists, there's something common, I think, between design, engineering, transportation, and really it all starts from an idea. An idea in the mind is what is first like a seed. It's so small and subtle, but if we if we nurture it just right so that it can grow and have a major influence, then it can be very successful. And so as we create those ideals, it's kind of like a little world in our mind. Whatever field we're in, if we're doing technology, transportation, or something else, some other type of design, we kind of know our field and know all of the implications of what we're doing. But we often don't realize that there is a very subtle, hidden other world kind of lurking deep in the background of our mind. And that is a much broader world of the implications of what we're doing, how it relates to technology, society, what's the philosophy underlying what we're doing? So there's a much wider world of disciplines that can come together. And so my interest is how to bring those together and make them succeed. And so from my background, I'm a person who grew up in Canada, and it's been very good to do collaborations in Europe, including in Italy and several other countries. And really, I'll share a little bit of what I've seen, because in those different areas, when we want to design a future world, there are different approaches. Now, science is in a bit of a special category because as a scientist, you must very carefully analyze what's there, how the world works. So you step back and you do very detailed work in understanding the way the world is. So that's why I kind of group engineering, design, and art into kind of its own category, because the approach is very different there, where you are creating, you're imagining a new world, a future world. And so I'm going to talk about how we can think about those disciplines very holistically. I feel like I'm very lucky because partly with design and the arts, part of the goal in the research world is to hope to be very lucky to kind of stumble upon an idea that is very new, very novel. That's needed in the scientific research world. It has to be very new. Nobody in the world can ever have ever thought of that before. And so by some miracle, there's been a lot of work with transportation engineering that has culminated in the next project that I'm going to show you. I'm going to show you a few different projects that are on the go, but perhaps the most sizable project right now is TransPod. So first, this is a new transportation system. So we are designing a vehicle that can carry passengers between cities at over 1,000 kilometers per hour. And so this is called the TransPod vehicle and the TransPod line, TransPod system. So we're designing kind of like an aerospace vehicle and infrastructure to carry it. And so you can see that it's almost like a mix between an aircraft and a train. This is the TransPod system. Now, if we step back in history, if you've ever heard of tube transportation, which is over 100 years old as an idea. It was first proposed about 100 years ago. By removing some of the air, bringing the pressure down in a guideway, you can reduce air resistance for these vehicles, and you can allow them to go much faster. So about 100 years ago, it was just a concept for future transportation. Over many years, that concept has been worked on by different people over decades. In the 1990s, there was an American company and a European company that were doing a little more research on that. The last few years, there was another version of it from the United States. You can call it Hyperloop, that version. But I tend to call it tube transportation, really to be honest and give credit to the original inventors about 100 years ago. So it's a type of tube transportation. TransPod is aiming to be the next generation of tube transportation. We have some key new innovations to make this vehicle work. So the TransPod system is designed to be a next generation of tube transportation. And I'll talk about some of the propulsion systems and really how its effect on society, how we intend to really imagine the future of transportation. And then the history of tube transportation. So you see again, like I said, early in the last century, it evolved over the years, and so the TransPod system is aiming to be the next generation. So we're quite happy with the innovations that we have been developing in Canada, and now also more in collaboration with European countries too. Now first we have to ask, why are we doing this? Well, currently we have issues with gridlock with congestion in our cities. So this is not only a problem in Europe, North America, there are many cities around the world, Asia, Middle East, where there is a distinct need for new transportation that can relieve the limitations of the vehicles that we have right now. Climate change is another key issue because even after all of the work that we've been doing to address climate change, we still have a major temperature increase, major problems foreseen in the next 100 years. A large part of that pollution, CO2 emissions, comes from transportation. Our vehicles still use fossil fuels for the most part. For example, when you fly in a plane, that plane uses fossil fuels, and it will for quite some time because we need an energy-dense fuel on the jet. So what I would say is we have transportation as it is, but we need true innovation in new fundamental designs of vehicles. And so we have to think big. We have to look at the big picture of future vehicle design. We can be inspired by the vacuum of space, and we can bring it down to Earth. And so that is the TransPod system. It's designed for implementing in cities and also between cities. And there are many, many different parts of that design. It's so long that it's impossible to describe all of the different engineering aspects that we are working on right now. When you see a rendering like this, so this is an artist rendering, so it's not actually clear infrastructure. This is just to help you see inside. It's actually made of spiral welded steel construction. And so this is the vehicle. You can say that it's built a little bit like a jet fuselage. And this is actually bigger than it might appear in the picture. So it has doors on either side. When you walk inside, it has rows of seats where you can take your seat, and then the vehicle leaves the station that you depart from. This vehicle, you can almost think of it as a plane that operates like a train. Or even better, since it works in a low-pressure environment, it's almost built like a spacecraft. So we actually have to work quite a bit with the space industry, including in Italy, actually. So then it is actually like a spacecraft that's built like a plane, and it operates like a train. This vehicle is propelled with linear induction motors, so basically moving magnetic fields that provide a force to propel the vehicle and also levitate it a little bit off the bottom of that tube. And then the infrastructure has two of those lines, one for each direction. It's designed to be linked to the electrical grid, and one important thing is that we made a key decision to not have any fossil fuels powering this vehicle. So there's no fossil fuels on board. It's fully electrically powered and linked to the grid. There's an option to install solar panels. Certain jurisdictions who don't already have renewable infrastructure, that is a good choice for certain countries. The overall design, it actually is designed to return a net positive amount of electricity back to the grid. And so, of course, you really have to think about urban design, too. So it's a major engineering project that we have been working on for a few years now and the next several years. All of the different subsystems, like an aircraft development program that we're doing with several in Canada and several other countries. But you also have to think about the social implications, the design fitting in cities and in the countryside, too. So there are many different designs for different country applications. And of course, you have to think about how it works. So the vehicle throughput, the passenger demand, because you have to make it work like a real transportation system. So it's not designed to replace train systems, replace high-speed rail, replace jets. It's actually designed to complement and connect with metro lines in cities. So we have to really carefully think about transportation issues when we design it. And so overall, there has to be a positive side for individual people. Why will they want to use this? Well, one example is when you buy a plane ticket, imagine this. You have to pay for your plane ticket usually weeks in advance or days, well in advance. And you have to come to the airport at that exact day and time. You can't just come at any day or time you want. So you have to show up at the airport. You also risk having the flight delayed. Even if you get on the plane, if you're not bumped from the flight, you take off. You have to deal with weather turbulence. The plane might get diverted to a different airport, and you might lose your luggage. So it's a very fixed experience. This system is designed to be much more serendipitous. So you arrive at the station whenever you want, you pay for your ticket, and you wait for the next TransPod vehicle to arrive at the platform. So it's much more like high-speed rail in that sense, but 3 times as fast. So the environmental benefits that governments can get behind, but also individual benefits too. So sustainability and convenience. And even the countryside, so designing how it works with flat terrain, with hilly terrain. We actually have an above-ground design and an underground design, depending on the hills. And one interesting example, in Canada, there was a new high-speed rail proposal in Ontario. And that is a really interesting example where there was a community of farmers in one region that were protesting the proposed high-speed rail line because it takes their farmland and cuts it in half. So they can't farm both halves at the same time. So a serious disruption. And what turns out is that they could actually get behind the TransPod system just because it's a light touch on the environment. So the landscape has only these supports, so you can drive your tractor underneath. It's a much lower impact on the land. So that's part of the urban design, and the rural design is very important. And now, how do the stations work? Well, we are actually working with an architecture firm in France, where this is an example of one of the stations. There are several different designs, configurations. This is one example of a Toronto design where we're based. And you actually have parallel platforms. So this is a little bit like an airport mixed with a train station. And so if I show you how it looks, we really have to work at designing passenger flows correctly. So it's really about the physics of the vehicles moving and the human issues too. So one of the proposals is between Toronto and Montreal. We actually have several different proposals in North America, in Europe, Asia, and the Middle East. There's kind of a distinct need for better connections to airports and between cities. And so if I just move through this a little bit, once you arrive in the station, we have the ticketing area. This station is actually designed to be connected to other modes, so an underground metro line, regional rail, and light rail as well. So that's all centered on a new part of the city. It's actually larger than the city of Venice, just this neighborhood that's new, that is ripe for development with waterways. And so here you see the different platforms, and so you choose your different, by the way, the vehicle goes through an airlock before it enters the station, so it returns to normal pressure, the atmospheric pressure. It can drive into the station. There's a little bit of a docking procedure with the doors there. And then we have a bit of a Spanish solution where passengers can offload on one side and load on the other platform, just to get the right amount of throughput of the vehicles. And so when you walk on board, you take your seat. The vehicle uses its linear induction motor engines to move forward and goes. And so that's part of the TransPod design. you have to really design this for humans. It's a part of the key research is enabling this type of vehicle to work, but it has to be designed for the human experience. So we even have medical research on what is a comfortable kind of vibration or acceleration in each direction. So the human, it's well documented how the human body feels the most comfortable. And in a way, it's very similar to when you are on a jet. So you're in the plane about to take off on the runway. So the jet is ready to go, the engines rev up, and you feel pressed into your seat a little bit. Here, it's very similar. It just lasts a longer time to get up to that higher speed. So we have the flight control system of this vehicle designed for a comfortable acceleration. It's not only for passengers, so we have also been working on a cargo vehicle design. So this is very interesting when you have freight carriers like FedEx, DHL, doing online orders. So this is not designed to carry rocks or iron ore between cities. It's most valuable for high-value goods that are lightweight. So those online orders, where right now you have a cutoff time, the latest time in the evening that you can order to arrive the next day. So part of the strategy is some of these carriers have an aircraft between cities every day. They want to save the cost of that cargo, that air freight, to be able to run it in a TransPod line and be able to shift that latest time during the day later. So you can order closer to midnight and still have it arrive the next day. Same with fruit and vegetable delivery, where there's a certain time criticality. And the interesting thing is in Canada, between Toronto and Montreal, with 10,000 trucks per day on that highway every day, there's a lot of cargo. With the freight carriers, they have informed us that once a TransPod line is built, they could actually fill that whole line with just freight on day one, even without passengers. So there's a big demand. And so this is designed to carry passenger vehicles and freight vehicles in the same line at the same time. You can have more passengers during the peak hours of the day and then more freight vehicles. And so then once you do that, you start to have this hub philosophy. So it's not designed to be a TransPod system only. You have to connect it to other modes of transportation to branch out in cities. Even at airports, where airports in some cases are landlocked, they have little space, they've run out of space, they want to be able to earn more profit from long distance routes rather than the short distance between cities. When you fly in a jet, most of the fuel is consumed at the beginning of the flight going up to altitude. There's a huge amount of fuel wasted in these short haul cities where the plane is going up and down again. And so those nearby short haul flights are the best case where we can relieve congestion at airports and be environmentally friendly, save on that wasted fuel, wasted fossil fuels. So there's a critical opportunity for airports and airlines to be part of these construction consortia or operate these lines. So it's really thinking about the business opportunities, how to execute this, because of course it starts as an idea, as a key innovation, and then it spreads to industrial. So we actually have a few collaborators in Italy for the aerospace industry, rail industry, and aircraft manufacturers. And this is actually an old list. There are quite a few more partners that we've started working with. So it's a very international project between Canada, Europe, and several other countries now. We actually just finished a feasibility preliminary study in Thailand. So Thailand is a very interesting country because it's an example of an Asian country very much on the rise, with new manufacturing and new opportunities. So there's a huge amount of growth in Thailand, but also congestion. And so there's a major opportunity for new transportation solutions all over Asia. And so it's very different between the opportunity. We have to design the system so that it meets needs in Europe meets different needs in North America and meets the needs in Asia and many other countries too. So it's really going together with the engineering design. And I would say that, for me, tube transportation, all the different designs, the people have been working on that for many years. That's a very exciting new concept, new idea. But for me, that is not enough. It's not enough to justify working on it unless you can have a key new leap forward, key innovations that solve that system, make it work better than anyone else has thought of before. So that is the strategy that we're working on with TransPod. So you have to focus on finding the mistakes that have made in the past, and with key new technology, we can make the system work better with a better business case and better operations and safety baked into the system. So safety is a core part of the design, but it starts with that key innovation, that idea, and with all of the different new partners, it really spreads from university research partners now, all the physics and engineering, all the way to more and more business development and industrial collaborators. So we really have to span the holistic design, the academic research, the engineering, industrial development, business development, the whole chain. So this is a very big project, and it's a multi-year project. And it really brings us back to the whole implications for society of transportation. These are worldwide flight routes between different continents. And part of the message is that, first of all, the aim is not to replace all plane traffic. So we'll still have plane travel between the continents, long distance routes for quite some time. And those TransPod lines are designed to really connect regions more effectively. But the other really core message is about the future of society. And because some people might say, well, we don't really need to pay attention to mobility, transportation, because in the future, everyone is going to have virtual meetings. So we're going to have holographic meetings and AI to help us. Well, I would say that is actually partly true, and that will help solve some of our climate change issues. But there's something to be said for face-to-face meetings between people. For all of you, our families, seeing our families, but also in professional environments, whenever you want to do major innovation, we cannot work in silos. There's an amazing effect when people can come together in the same place, meld minds, and innovate. And so there's going to be a very important aspect of face-to-face meeting for quite some time, and meet. So it's an important message that we do need to solve transportation problems. Our cities have fundamental limits. The AI solutions and autonomous cars, those are very important. Those are actually a different way to use kind of software to use our existing vehicles in a better way. But those software solutions have a limit. The capacity of our roads has a fundamental limit that we cannot surpass with software alone. We do need to look at the fundamental physics of how we build our vehicles, and that is hardware solutions. Even though we have drones, autonomous aerial vehicles, and many other innovations, there's a big need for long-distance routes. How can we connect our cities in a fast transportation method? So that is TransPod. So TransPod is a very multifaceted project. It includes all parts of engineering, design, architecture, and looking forward to bringing it one step forward each year. All of the different countries that we're looking at for different routes, I would say it's a little bit like a horse race. So while we do the engineering, all of the different parts of the vehicle and the infrastructure, we're also talking with different regions and cities worldwide And all of them are taking little steps forward, looking at the TransPod design, and sometimes one seems to be in the lead for being able to do more studies, and then another one catches up and overtakes them. So all these cities are moving forward, and so it's anybody's guess which is going to be the first city that is going to be the first one with a TransPod line. I have a few guesses, but that is TransPod. And so I'm happy to answer questions about that. And I just want to step back a little bit just for a moment because TransPod is very multidisciplinary design. We are here in Milano, and that is a great place to think about the future of design. How can we design for benefiting society? And so science, engineering, design, and the arts are all needed. And personally, so with my background also as a composer of music, I've worked with a couple of different interesting projects there. I would say that the arts shouldn't necessarily be at the bottom there. In some ways, they should be at the top of the list. It's been said that art is what lays bare the questions that have been hidden by the answers. That was Baldwin. So it really addresses the underlying philosophy of the world around us. So the arts are very important. And I've noticed that the strategy for solving major engineering projects that affect the world is in some ways similar to artistic design. And so I've kind of used that approach in composing music, where you really have to look at I would say the lowest form of music composing is just looking at notes on the page, but the highest form is designing a new human experience. So whether that's for engineering or an artistic experience, it's really about designing something that hasn't been imagined before. And so I'll show you kind of one completely different example of that. This is another project. It's called the hydraulophone. So this is another previous work that we've worked on in Toronto, Canada. This is a musical instrument. It's the world's first musical instrument that makes sound from vibrations in water. And so this is a great example where physics, engineering, and the arts have to come together because it has such a different playability, a different sound than other musical instruments. You can't just take piano music and put this play on it. It actually has expressivity that you can't achieve with any other musical instrument. This thing is full of pipes inside, 45 pipes in this case. And when you touch the water jet, you push on it, block the flow, it diverts the water back into the sounding pipe of that note and makes sound. So you can move your finger around very carefully to adjust how the resonance happens in the water. And so, just like TransPod, you have to look at the past and the future. With this project, we were looking back to see if anyone had done this before with a musical instrument that created sound from water, from vibrations in water itself. So you have examples like ocean waves crashing on the seashore in caves. That's actually not a hydraulophonic instrument. It uses the air to help with the resonance. We look back in history, we actually found that the ancient Greeks had something they called a hydraulis. That was their water organ. But it turns out the hydraulis only used water as a source of pressure to drive air through organ pipes. So it's just an air instrument. So really, it turns out that this is the world's first instrument to make sound from vibrations in water. So we kind of hear the voice of water as you play that. So that's we've had performance on this is actually shot several years ago before TransPod, and we've had performances in New York and Europe and a few different places, and so this is a composition that I wrote for a duet. There's other pieces where we've done kind of a concerto type of piece for hydraulophone and orchestra, where you actually have, now you finally have the missing part of the orchestra. In the past, you're seeing how you can play, you get a lot of expressivity. So in the past, you have orchestras organized by instrument, strings, percussion, wind, solid, solid, gas. So Steve Mann noticed this problem where all previous instruments were organized as solid, solid, and gas. So now, for the first time, we've actually had a orchestra, a concerto, with solid, liquid, and gas, so a complete orchestra. So that is an example where physics and engineering and the arts come together, and I would say that human perception, just like with TransPod, with designing the control system for that vehicle, you have to look at the mathematics of and the biology of the human experience, the human physiology. And even with music, I would say that composers have a set of rules that they follow for how to write a piece of music, how to design harmony and dissonance, how to deal with orchestration. They have many rules that they follow, but often they don't know why those rules are the case. They just follow. That's the way music works. They just know that you have to do it this way to have a certain sound. I would say that the reason behind those rules, about half of those, about 50% of those rules of human perception of sound and music are from the biology of the ear and the biology of the human brain. But the other 50% comes from the fundamental mathematics of the universe. So mathematics itself governs about 50% of the rules of music, of music composition. So what that means is that if we ever discover an alien civilization at another planet, about 50% of the rules of composition would have to be the same from the fundamental mathematics of the universe. So really the math, the arts, really kind of come together when you have human perception. And so my goal for many of these projects, this is another example with the world's first sensing of sensing itself. So that's valence flux. So this was another research project in Canada where we aim to have medical applications as a better diagnostic of human perception. So that's called valence flux, sensing of sensing, seeing sight and visualizing vision itself, sensing sensing. And I would say that all of these projects, the common element is thinking holistically about the implications, about the different fields of design, and what its effect is on society, finding a way that it can be done well. And definitely with the TransPod design, it's a type of architecture. And we can actually be inspired by Vitruvius. So he was a ancient Roman architect. And he had a very good point about what constitutes the best design of architecture in his case. Arches. Arches are designed by architects back in those days. So being able to design with strength, with usefulness, and with beauty. That was his statement on the best designs in his philosophy. And I would say that as we design future transportation systems, engineering, AI, we have to think about the effects on society. And I think we need a next benchmark of design for the coming age of artificial intelligence, of new transportation, and so on. because it's a rapidly changing world. And I would suggest that, in the past, I spent some time in Silicon Valley, and university research, and with starting businesses, that all of those start with a seed of an idea, that light bulb you saw before, a seed, a very tiny seed. And we have so many ideas. We can have 100 or 1,000 ideas, but we need to decide what is the best project that we can do, whether we're an artist, whether we're an engineer, whether we're an entrepreneur. And so those ideas, you can't, first of all, it has to be done well. It has to solve a major problem. That was the strategy with TransPod. Not only tube transportation, but what are they all doing wrong with tube transportation? So that's the key innovation behind the physics of the vehicle, the propulsion systems, the control systems. So you have to have a key new breakthrough in vehicle propulsion. So that's quality. You have to design it well. But also novelty. So you have to do something that nobody in the world has thought of before. There are many really good ideas, but the common experience is you can go through 100 or 1,000, and 99 or 999 of those ideas somebody in the world has thought of before. So you have to really find the right idea that is missing in the world so far. And then impact. So all of those ideas have to have a way that they benefit people or that they can excite people. And that's the key need even with entrepreneurship. So you have to be able to engage governments with new transportation policy. You have to engage industrial partners for collaborating on design, engage universities. You have to think about how this idea will grow from just an idea to engineering, to design, to a large-scale project that can be implemented and has a good either a business strategy, or sometimes some ideas don't need to be a business. Some ideas are best as cutting-edge research in the academic world. And so there's always a best place for an idea to have world impact. So it's very hard to find just the right project. So I think I'm very inspired by the design that happens here in Milano, many different forms, and I think as we go forward, we need to be inspired by more Da Vinci, multidisciplinary thinking, how we can think of the holistic parts of a problem, whether it's art, science, engineering, and have a major world impact. So that is my attempt to explain how we can solve some problems. So I'd be happy to take some questions. Thank you.
Eccomi. Beh, non so, adesso...
Okay, here we go. Well, I think that there are questions. I mean, I do have so many questions now. First of all, really would like to thank Ryan, because Ryan once again has highlighted this point, which is so important in terms of research and when it comes to new technologies and new look on the future. I mean, he talked about the interdisciplinarity and even multidisciplinarity. I mean, so we don't have to have silos, we don't have to have compartments, but rather we have to have integration. And only if you integrate will you be able to get great results. So maybe we talk about a sort of new humanitarian culture. In this case, I'm talking about a digital culture that can recombine and then looking for new pathways. So mobility has to do with technology, and mobility plus technology bring about new ideas. There's an incredible highly level of knowledge, curiosity, inspiration, history, knowledge, culture. So the presentation for me was very interesting. This is also our position in Meet the Media Guru, and this is also one of the key highlights of our conferences around mobility. So we want to, to open up to new reflections, to new ideas, much more than the technological, wonders, but we also have to assess the impact that this has on life and society. Okay, this was not a question, but just a comment. I know that you're curious and eager to know more. Now, what Ryan told us is not science fiction. This is evidence, this is facts. And this is what they are doing in Canada. And it's a sort of a mosaic methodology. I mean, they have engineer, and then they have design, and then they have the factor of, there's physics. So it's a multi-level systems. So we have plenty of boxes opening and closing, and then the projects are now being shaped and meeting the needs of society. So some ideas at the very beginning, and then in terms of application, Ryan kept talking about the impact that all of this may have on our geography, for example. And for example, the tube between Toronto and Montreal. And then there's another fascinating connection. I mean, the fact of connecting cities. So this is, an economical, physical geography which is being reshaped today. Anyway, let me stop here, and let's get questions for you.
Francesco, se anche tu vuoi dire qualcosa, siamo qua. Prego.
Hi. Can you hear me? Yeah?
Metti il microfono bene così. Ok.
Okay. First, I think that your project is just amazing, and that the hydrophone, is it the name? It's the coolest thing I've ever seen in my life, maybe. I have first one question that really is hitting my head. Like, will we have the Wi-Fi on the TransPod? No, just joking. Just joking. No, I was thinking about the conference of George Amar. He was talking about how we can use the time that we pass on the public transport as a time of our life, not a waiting time. And so I was wondering, how do you think to design the inner part? Because I've seen that in one slide there was like the business class, so maybe there will be a kind of a separation like on the airplanes, or maybe you're thinking like designing different environments inside.
Very good question, yes. The vehicle design for the TransPod vehicle is right now we are working on all of the different subsystems to make it work, and so we're very excited about that. But the interior is actually a little bit open-ended. It's very interesting because if you compare to aircraft manufacturers, so Airbus, Boeing, they often leave the open area inside open so that the different airlines can install the seating whichever way they want. So some airlines want to get as many passengers in as possible. Some airlines want to have a big legroom. The TransPod line it's designed to be flexible for different countries and different cities. You look at some countries where governments, such as in Europe, they want to implement transport projects for the public social benefit, so to better connect cities. So with each of these lines, when there's a consortium, a construction consortium, the design is to have the TransPod IP, but also the construction partner, financial partner, and governments, where they want to design it to benefit people the most. Whereas the United States maybe is a good example of the other side, where it has to be completely, it's likely to be completely private sector funded, where it simply is about economics of the system. So we have to design the economics to work with the right ticket price and to be profitable enough. So so all of those cases have slightly different applications. So there's quite a bit of flexibility in how the layout is designed. With Wi-Fi, of course, yes, it's all of the vehicles are in constant radio communication with the infrastructure. And so all of the control systems are linked. We have multiple redundant fallback safety control systems. So if one fails, the next one works, and then the next one works, and the next one, and then we always have a hardware backup system so that the vehicles can safely stop. But so all of that is constantly in communication, and so we have another channel that we can add Wi-Fi signals. Yeah. Yeah. Thank you. Grazie.
Hi, Riccardo from Milan. I followed the Hyperloop race in Delft with Delft University with the design of this Hyperloop project. And it seems to me like the flight industry, like Blériot, they're the first pioneers in the flight industry, but then it took many technical nuances, new ideas in order to transform a Blériot plane into a commercial business. If tomorrow the Canadian government launches the bid for the transport between Montreal and Toronto, are you able to start right now and to provide a commercial service to provide the people tomorrow?
Okay, grazie. Yeah. This is a good question. It's all of the different parts of our development. So the civil engineering, electrical engineering, rail certification, and so on. All of those are being designed in parallel. Where right now we're doing all of the subsystem testing and design in different countries, and so it's all lined up to converge towards our test track plans, towards certification. So we're already working with the European Union to start the certification process. We have a goal to finish the certification hopefully around 2025, and after all of the design is complete. And then after that we aim to start the first contracts to build different lines. And so then it takes a few years of construction of those lines. Even before then, we have a strategy of testing at a large scale. So we've had a construction permit approved in France for our first test track. So this is a half diameter test track, up to 2.5 kilometers long. And so that's in France. We also have been working in Canada for the next stage, which is a full diameter version of the vehicle and track for the certification process. So that's that land has actually been made available by the government in Alberta, in Canada. So all of those parts of the project converge towards construction.
È tutto molto reale, prego. Sì.
Thank you very much, first of all, for not losing my luggage. I'm very satisfied about that. Now, the question is about the territory, the land. Because I was absolutely intrigued by the idea of having the farmer against the fact of having something cutting into the land.
Mm-hmm. At ground level, yeah.
What about the impact, especially for some regions who are pretty complicated to handle? Italy is one of them because we are full of mountains all around and in the middle. So which is the impact on the land, and which can be the tricky situation going from one country to another, or from one land to another one, even having different frontiers and different country and different markets and different approaches.
Mm-hmm.
Thank you.
Thank you. Yes, we've noticed that the proposal for high-speed rail from Italy up to France, I believe Lyon, there were some concerns, environmental concerns for high-speed rail about noise concerns. So we've actually done some pretty careful work on sound issues, and in a basic sense, with a TransPod line, when you have a low pressure inside the tube, it's about 99% close to outer space. So sound does not travel well in a vacuum, and so effectively that vehicle, even though it's going at high speed, it's very quiet on the outside, and so that's part of the design. And so really you have to look at the noise impacts, the land impacts. We actually have computer-aided design to help us optimize the route, so in terms of its altitude and position. So we can actually take into consideration the constraints, the local constraints, so heritage properties and ecological zones, and optimize the route around that.
Uno, due, tre. Facciamo prima i piccoli, i giovani. Scusate, ma non per mancare di rispetto.
Hello, I personally like trains, and I'm really curious if the train, how it's called?
The TransPod.
The transport needs to pass from one place, from one rail to another one. How can it pass?
We actually have a design
exchange.
for that. Yes. Sorry, is that your? Don't mean to interrupt.
Yes, how we can pass from one point to another, but there's not a tube, and it need to change tube.
Thank you very much. Yeah, no, that's. I'm glad. See, he's
Grazie.
thinking like a. This is.
Guru onorario.
You're thinking like a rail engineer, so that's very good. So, and these are all we have to not only think of the aerospace side, but also the rail railway-like considerations. So yes, exactly that. So that is part of the design. You didn't see it in the pictures, but we actually have a part of the system that's able to switch vehicles from one to the other. And also, even in stations, we have sort of a setup where we have the vehicles can actually go into multiple parallel tracks, because when you have many vehicles coming in at a time, you need to spread them out into a few different platforms because you don't want the passengers to run on board, take their seats, run off. You want to give them some time so that spreads out the load.
Scusa, tu come ti chiami? Come? Valerio. Se vi presentate anche un momento di incontro tra di noi. Almeno il
Alessandro.
nome, Alessandro.
And I was, I think that the instrument, the water instrument, is crazy, fantastic. I'm a piano player, so I was stunned. But I want to ask you a question about the TransPod. Two questions. The first one, I didn't understand very well what is the trade-off between the frequency of the TransPod and the capacity, because I understood that it carries around 100 people per time, maybe something like that. Because nowadays the Frecciarossa, for instance, which the red arrow, is carrying around 500 people at the frequency of between Milan and Rome, maybe more than a train at an hour. And the second question is, are you sure that, what do you think is the landmark of the development and of the trains that are run by electricity right now? Because they might be challenging also your speed in a very few years.
Okay, that's a very good question. So, I'll answer that in two parts. So one is with high-speed rail systems. So we've worked very, very hard to on the technology to be able to have. I can't speak for the older Hyperloop, which are different, but the TransPod line I can speak for. So the TransPod line, we worked very hard on the new technology there to reduce the infrastructure cost. So that's partly simplifying the infrastructure, but some key new technology to make that work. So the cost of the infrastructure, you can actually compare that to maglev lines. So some of the other tube transportation designs are a little similar to that, so the traditional maglev. Currently, the fastest train in the world with maglev actually is in China at the Shanghai airport. So that's quite fast. Unfortunately, that line is losing money like crazy, partly because it is maglev technology. It's a very expensive technology. So it's about $100 million US per kilometer to build. And so we've worked very hard to get the TransPod design to be quite different. So it's more around 30 million US dollars per kilometer, about 20 million euros per kilometer to build. So then that's actually similar to high-speed rail to construct, but 3 times as fast. So right now, high-speed rail has its limitation. And actually, you've seen some tests of high-speed rail where they try to push the vehicle to quite a high speed. So rather than maybe 300 kilometers per hour, more like 500-600 kilometers per hour. But unfortunately, you can't have passengers on board. You have a couple of crew members that are a little bit afraid for their lives, and then they test the train and stop it. And then at that point, the parts of the train are actually partly broken at that point, so the whole train has to be overhauled to fix everything that was damaged at those tests. So there are some limits. So anyway, the hope is to build this system, not necessarily compete with high-speed rail, but to connect with it even, and with the airlines. We think that rather than the airlines also being angry about something like this, the idea is also to involve them, so some of the airlines might end up being the operators of a TransPod line.
Ancora una domanda? Ma c'era, mi sembra, un'altra persona là? No. Prego. L'ultima. Quali domande ci sono? Una? Ecco, c'era se prima.
Hi, I'm Christina.
Due domande.
Thank you, Ryan, for your presentation. It was really interesting and challenging for our future. One concern about the impact on health. You said that it's the compression and the trip is at least 45 minutes. So when we are in a plane, we just are looking for the end, it's 3 minutes maximum, something like that. But what about 45 minutes of the compression at such speed? It's still on research? It has already been solved, or what's the procedure?
Thank you. Thank you very much. No, that's a core part of safety has to be, at least my point of view, my strategy is safety has to be designed, kind of baked into the system fundamentally. And so that's very different actually from jets. So with the TransPod line, we can actually refill the air pressure in the tube quite quickly. And then the vehicles can stop, and it's normal pressure. So it's not 45 minutes. It's well under a minute. It's a matter of seconds, and so that then the vehicles can safely slow down, and even passengers can evacuate. The difficulty with jets, and that's part of the reason why jets, they've had to work so hard at safety design, because the jet can't land instantly. The pilots have to bring it down, especially if there's a loss of pressure. The pilots have to dive the aircraft down to a certain altitude where you can breathe again, and then they have to look for a runway somewhere nearby. So there is quite a long time delay before the plane can land if there's an emergency on board. So whereas here we have a line that's at ground level already, we have emergency exits designed at regular intervals, just like on a metro system. So you can exit the tube.
Bene, c'era ancora una domanda, prego. E poi prego.
Good evening, and thank you for the presentation. I'm pretty curious, and I have like 2 questions. The first one is like you told us about there's an instant when we'll be transiting from the vacuum to the atmosphere. So what is the impact on the passengers and as well as the shell life of the exterior life of the pod itself?
Oh, yeah.
And like, okay. And
That's
secondly,
yeah, okay.
When we have to give it a maintenance or something, how does it like come out of the tubes? It is there inside vacuum or maybe atmosphere. Like, how do you put it down for the?
Sure. Thank you. Could we show the screen on my computer, just to help people? Let's bring the laptop back if we can. Oh, there we go. Good. Okay, thank you. So if we go down here, let's just see the vehicle. So this actually is built like a jet, where it has actually bulkheads in there that hold the pressure. So it's a little bit confusing, but the outside air is normal atmospheric pressure, then the low pressure in the tube, and then in the vehicle, it's normal pressure again. And that's same as an aircraft. They have a cabin air system that circulates the air and holds the pressure. So this is just the same as on a jet. So when the vehicle goes through the airlocks and then arrives at the stations, the passengers don't notice any difference because it stays the same for them. And yeah, so good. Good. And so yeah, that's core part of the design. And anyway, some of the pictures of all of these things, there are videos that help to explain. So you can go here with some of these projects and see some of that.
Bene, allora io grazie, un applauso a Ryan.
Thank you so much, Ryan. Big round of applause for all of you and for Ryan. Okay, so please write down that this is, the second meeting. There will be at least 4 meetings that we will be talking about mobility. Today's mobility, but also a little bit of future mobility. Okay, so this time, we have to write down this sort of information on environmental impact, focus on human beings' health, and it's a sort of an inspiration that we have here. So basically we can, plan or design new schemes and new diagrams, shuffling cards to find new solutions. So there's plenty of food for thought, and now the video will be online soon. If you want to know more about this, if you want to take a deep dive into this, you will be working with Fondazione Bassetti. We will keep exploring, and then eventually we will draw a sort of a map, and of course everyone can contribute personal considerations. So just give me 2 minutes, please, because I want to invite you to the next meeting. Jeffrey Stapp, here we go. He works with a major research center funded by Italian Piaggio in the United States. He's a digital humanist. He works for Digital Humanity DH. They are developing very interesting prototypes on mobility. We will also have other meetings with Meet the Media Guru, but I'm sure you are Guru, let's say, fans. So thank you so much for your participation here in Milan tonight. And also would like to thank once again the Bassetti Foundation. Okay, so let's keep in touch. Thank you so much. Enjoy the rest of the evening. Bye-bye.